Good morning, good afternoon, good evening, wherever you are. My name is Matthew Wierro-Finney. So hopefully you're here to learn about the Zen Framework 2 view layer. I named it Views, Renders, Resolvers Online because it seems like a very complex topic, but as you'll see as we go through, it's really not that bad. So who am I? I'm Matthew Wierro-Finney. I'm project lead for Zen Framework. I've been working on Zen Framework since, I think January of 2006 or thereabouts, but full-time since the end of 2007. I've developed a ton of stuff on Zen Framework 1, and I'm leading the Zen Framework 2 initiative right now. I'm actually the author of the view layer that I'm presenting on today, so I do have intimate knowledge of the topic. In general, though, I'm a PHP developer. I code in PHP. I live, breathe, and eat PHP on a daily basis. So that's my credentials, really. A lot of you may be asking why a new view layer for Zen Framework 2. And really there's a bunch of different reasons. First off, we have a new MVC architecture. And while, generally speaking, developing controllers looks and feels a lot like developing in Zen Framework 1, there's quite a few changes under the hood, and it was going to require changes to how views are done. The other thing is we really needed to decrease decoupling. I have another slide on this later, but basically ZenView was doing too much and at the same time not enough. And we needed to do something to make it a little more manageable and give it more flexibility. And one of the key things that we're noticing, this is a mobile world. And as a result, there's a lot of APIs and things going on that people are needing to be able to serve different content. They need to be able to serve HTML for those browsing on the web, but they also need to be able to serve to their APIs. You get providing JSON, providing XML, providing other custom formats. So there's quite a bit of stuff that we really wanted to address with ZF2. And as I alluded to, ZF and the Zen Framework 1, ZenView is really doing too much. In my presenter notes I have here, ZenView takes the idea of just do all the things. I put in this chef robot because I felt that he symbolized a lot of what we're trying to do. We're wanting to flip burgers, or wanting to whisk eggs, stir up some cake batter, and chop up a bunch of walnuts and everything. We're trying to do everything at once. And this isn't good. In particular, ZenView is responsible for not just the rendering of template, but resolving the templates requested to a file, managing helper and filter creation, registry, invocation, basically their entire life cycle, acting as a variables container, and a bunch more stuff. And it's doing too much, and it makes it really hard to change things. One of the things a lot of people want to do is, tweak just one little aspect of it, and you can't do it without knowing the internals of the view. So we decided that it was time for a slightly new architecture and a couple advancing things. So there's a lot of different things going on. First thing I want to talk about are view models. And I think of view models as kind of like the ingredients of your view. You may use them, you may not, but they're present. These are the things that are, you're feeding into the view. In specific, it's a container for variables and a container for the template name and potentially some renderer options. Some other things that we built into the view models is this idea of having nested view models. So basically we can create whole trees of them. And what's nice about this is then you have encapsulation. You don't have to worry about collisions between variables as you render different view models, which is really nice. The other thing that, because we're using trees of view models, we want to be able to indicate a new route for the tree at some time. So you may say, I don't need anything above this. I just need from here down within the tree. And so we wanted to be able to do that. So the view model basically provides us a structure and data that we can utilize within the templates that we use when rendering. The next item are resolvers. And I think of this as a recipe box. We know what the recipe is, we know the name of it, but we need to look it up and we need to pull out that recipe card. And that's what the resolver is really doing in this particular case. Basically, it's going to resolve a template name, and they're just names now. It's not necessarily a file, it's a name. We're going to resolve that name to a file or some other resource that a renderer is going to use. So the reason I say some other resource is because you may actually want to store templates in a database, or you may be utilizing templates out of a caching layer like an Memcached or something like that. And we want to be able to support that. Again, in Zen Framework 1, this was not possible. The only way that you could resolve a template was the hard-coded logic within ZenView. So having this resolver layer in here decouples that and makes it possible to use alternate strategies. Next are the renderers. I really enjoy this part. The renderer is really kind of like a chef. And what he does is he says, hey, give me a view model, some ingredients, and tell me from there. I'm going to say, okay, well, we've got this recipe that we want to use, and I'm going to take this recipe and these ingredients, and I'm going to create something out of it. So the fun part here is that we can take that view model, and the view model composes the name of the template that should be used. So we take that, we pass it on to a resolver, which gives us a resource that we can, that represents the template, and we start doing stuff. So it's a lot of fun. Now the thing is that in any good kitchen, the chef is, fairly important, but he shouldn't be doing all the work, right? So we then have what are called helpers. And the helpers are sous chefs or prep cooks, so that sort of thing. And what they do is they do a lot of the work behind the scenes. So if you want to do something like render a table, you can pass in some data to a helper, and the helper can go and create the markup for that. I don't have to do everything myself. If I want to do a URL and render a URL, I need to consult the router and everything. I can pass it on to a helper to do it. So basically, the idea behind helpers is that they're usually stateless unless they need to compose some functionality in order to do their work. But otherwise, they're typically stateless. You pass it something, and it determines what sort of markup or what to do with that. So that's the other part of the rendering solution, is that we have our view models, we have our resolvers, and the renderer then also can delegate the helpers in order to do the work of actually creating something. Now, kitchens are all nice, but who is actually doing, what is this all for? Well, the client is saying that I want a representation of some sort. So in the case of a restaurant here, you are the clientele for this restaurant. You go in and you talk to a waiter or a maitre d', and the waiter then goes back to the kitchen and says to the chef, hey, they would like this. And the chef goes and prepares it, and they give it back to the waiter, who then does a nice presentation of it to the client. And so we have the view object within Zen Framework 2 is basically, hey, I've got this, I'm taking this information, let's go pass it on to the renderer, the chef, to get a representation back, and then I will return it back to the user, to the person, probably on a plate. But that's the sort of thing that the waiter then takes care of, is, how do I present it to the restaurateur, the person coming in and eating. So these are the various pieces of the view layer within Zen Framework. And we'll get into some of these details now as we go through. Now the first part is that, this is all nice and dandy, but when it comes down to it, you just want to be able to render something within your MVC application. So of course we wanted to have a lot of deep MVC integration within the framework. So some of the goals that we had, some of the chief things that people have asked for are things like, hey, I need to be able to do layouts. I want to have this enabled by default. For those of you who used Zen Framework 1 from the very beginning, we actually didn't introduce Zen Layout until the first minor release. And so, a lot of people were begging for it. They were, creating their own implementations and everything. And as a result, when the Zen Layout came out, some people were like, well, I've already got a solution in place. I'm just going to use what I have versus using the available functionality of the framework. We wanted to skip that step in Zen Framework 2 and just have it available from the beginning. Another thing, we really quite often need to be able to serve 404 pages, and we need to do so in an easy way. In Zen Framework 1, we did this through the error controller, and so it had some switching logic and everything. But we wanted to make this a little bit more pluggable and also more customizable. So we wanted to make this a goal from the outset. Same thing goes for general error pages. If you throw an exception within your logic somewhere, we want to be able to provide a nice error page by default. Other things is we wanted to have, of course, action-specific views, and we want to make this as trivial as possible. So one of the things we did in Zen Framework 1 was the view renderer. which was an action helper plugin that would go through and take care of rendering a view when you got done executing an action. So we wanted to have something similar to that, but not quite like that. That solution was always fairly imperfect. But we wanted to have some capabilities like this. We wanted to make it very easy for people to do. We wanted to have some same defaults for view selection. Another goal was providing basic rendering capabilities and response injection. We wanted to have this basically wired up for you from the outset. So the way we went through this, or I'm going to go through each of these points as we through the next few slides. So when we start with layouts, the thing I did here was I took the MVC application now injects a view model into the MVC event. So you can actually grab this and say get view model off the event that's slung around. We inject it right off the bat, and we actually inject it with a layout template already set. And this is done through the default rendering strategy. So basically what this allows you to do is if you have this template resolving somewhere, you're going to have your layout enabled right off the bat, which is fantastic. There's also what's called the inject view model listener. And I talked about how view models can be trees of, nested trees of view models. The way that the layout works is that it takes the view model returned by an action controller. We'll talk more about this in a minute. It takes that and actually adds it as a child to the layout. And so this allows you to capture the content to a specific key and from there do something with it. So this is a really nice capability that we enabled from the outset. We also built a layout controller plugin and a layout view helper. And you can basically with each of these, you can now access the view model that representing the layout from your controllers or your view scripts. And this allows you to manipulate it. So if you want to add values to it, you want to pull values from it, whatever the case may be, you can now do this. 404 pages are done through what's called the route not found strategy. And this is invoked in a few different ways. First off, if routing fails, this is going to get invoked. And what's really cool is that a special event is triggered, this strategy is then invoked, and a response is returned right off the bat. We can actually bypass a whole segment, a whole section of the workflow of the MVC right off the bat. Same thing happens if matched controller does not actually exist. The same thing that will happen as when routing fails. And so we're able to display a 404 relatively quickly at this point and bypass a whole bunch of different steps of the framework. The other thing is if your controller sets a 404 response status in the response object, the route not found strategy listens after dispatch and it says, oh, we have a 404 response. And so at this point, then we're going to render the not found template that is registered with us. So this is all part of the route not found strategy. Again, this is registered by default. This has a configuration setting for the not found template, so the template you want to display for 404s. And you can also choose whether to display the reason for the 404 or the exception message if you desire. So these last two settings are really useful when you're debugging, for instance. You can find out, oh wow, we got the 404 because it couldn't find the controller. Oh, we might need to add some configuration somewhere. Or I got the 404 because this action doesn't exist. Well, I wonder why that is, and so you can go and find out. Next one is the application error pages, and this is done through the exception strategy. Basically, this will get invoked only when you throw an exception from your controller. And when you do so, it will then say, oh, an exception was found, occurred, so now I'm going to invoke this exception strategy, which is going to set up a special view model with the exception template, and I will let it know whether or not to display exception messages and pass it on to the renderer, and we're done. So this is a really nice, simple one. One of the things you'll notice is each one of these pieces has basically a listener associated with it. And I wanted to call attention to that because what it allows you to do is as an individual developer, you can go in and craft your own workflow. So if you don't like the way a particular strategy works or if you don't have a need for it, you can choose to provide a substitution or just eliminate it entirely. So this is actually one of the places where Zen Framework 2 really differs from Zen Framework 1 in that you have a lot of granularity with how these different listeners work. With your action views, so within your controllers, you have a variety of ways that you can actually communicate to the view. Now, one thing that's very different between Zen Framework 1 and Zen Framework 2 is that we do not inject a view object or a renderer object as the case was in Zen Framework 1 actually. We don't inject it into the controllers.
the idea is that you just simply do some logic and you return some sort of value, and from there you determine what to do. So the way that we set this up is we said, okay, what are the different ways that we can enable this and make it simple for end users? So one of the things you can do is simply return an associative array or a null value. Return a null value, create view model strategy will create an empty view model basically for the content. And later on, we'll also populate that with a template. So it will just render the template with no substitutions. If you pass an associative array, it's going to create a view model and give it that associative array as the variables that it contains, so the ingredients for your view. So that's the create view model strategy. From there, we can then also populate. The other thing that we can do is we can return a view model that's already populated with variables. I'm actually going to demonstrate all of these later, so you can worry about what the code looks like later. But what happens then is inject template listener list, and it says, hey, is there a template associated with this view model? And if there's not, it's going to inject one based on the current controller, and actually potentially later we may actually add the namespace that we're in as well to make it easier to differentiate between different templates. So these two will actually, the create view model strategy and inject template listener will actually often work in tandem. So you can return an associative array, and it will create a view model and then populate it and inject it with a template. The other thing you can do, of course, is return a fully populated view model that includes a template. So if you want to override or specify a specific template you want to use, you can do this. And then if you don't want to even bother about rendering, you can simply return a fully populated response object. So if you return a response object, we'll now bypass everything else and move on. So this is another important thing to do. Now, finally, we've got rendering and response injection. And so what happens, I just realized we're missing the backslashes here. So there should be a backslash between Zend and MVC, between MVC and view and MVC and strategy. And actually, that should be Zend view strategy. Anyway, there's some errors on the slides. I'll correct them after the talk and before I post them. But basically, we have the default rendering strategy within Zend MVC view. And that registers Zend view strategy's PHP renderer strategy. What this basically does is it returns a PHP renderer during the render phase. And so we know that there will be a renderer available. And then at the end, it will inject a response with the results of rendering. The other thing is that the default rendering strategy acts as the sole event listener for the application's render event. So again, lots of little details under the hood. The basic idea here, though, is that we're enabling a default renderer, the PHP renderer, which is analogous to Zend View and Zend Framework 1 by default, and we are making sure that the content, the return from the rendering is going to get injected in the response. There are ways to override this, and I'll be showing you those later. But we've set up this whole infrastructure that allows you to basically go in and do the things that you typically are going to do 80% of the time without needing to configure anything at all, which is fantastic. So the summary, again, is that there's a lot of event listeners, and they're set up to enable the most common use cases surrounding views. So making sure we have layouts, making sure we have 404 pages and error pages, making sure that it's easy to hint to the view what we need to render, as well, what's template to render, as well as the variable substitutions that we want to add in there. You can override almost any portion of this using either DI or by extending the Zend MVC Bootstrap and overriding the setup view method, which goes through and registers a lot of these strategies. So if you wanted to, you could just provide a substitution for any of these via DI using aliases. Or you can go through and modify the Bootstrap, extend it, and override the setup view and register your own strategies at this point. So that's the architecture and the MVC integration. So now let's get into the part that most people are probably really interested in today, which are common tasks. How do I do this? So now we get to our code. So the first thing is I talked about resolvers. Now resolvers are basically taking that template name and trying to resolve it to a resource that the renderer can use. By default, we register an aggregate resolver. And an aggregate resolver basically says I'm going to take a LIFO queue of different resolvers, and I'm going to pass the template name to each of these in turn until one of them returns a resource. So we have this and we register it with two different resolvers, the template map resolver and the template path stack resolver. The template map resolver basically takes a hash map of the template name to a specific file. So this is going to be the fastest lookup possible, which is fantastic. The next one is the template path stack, which operates the way that those of you familiar with ZenView and Zen Framework 1 are going to be very familiar with. You basically provide a stack of paths to consult, and it has the default file extension associated with it, .html. And it goes through and it tries to find it. So it's very, very easy. Resolver configuration right now looks like this. And I say right now because right now we're using DI for everything. This is subject to change by Beta 4. We're introducing a service manager component most likely, which will mean that we can have flatten the configuration quite a bit if we want to. But basically the way this looks, and this is pulled directly out of the application modules config in the Zen Skeleton app. What it does is it goes through and we define two injections for the aggregate resolver, and we inject our template map resolver and our template path stack. Those are lines 3 through 8 in this example. And then what we do is we define configuration for each of the template map resolver and the template path stack. The template map resolver, basically, like I said, it's defining a map. And so in here, what we typically will do is things that we know for sure we're going to be needing to resolve regularly, things that we know are defined in stone, views that we know exactly. This is the name of the view, and it's going to resolve to this path. This is a good place to put those. So we put the layout in here because we know that the layout is going to be called every time. So we want that to resolve as fast as possible. Now the template path stack, we just simply add paths. And it's good to add a key here, usually the name of the namespace that you're using, simply so that when we merge all these different paths, they are merged in the order that they were originally done, and they all have unique keys. And as you see here, we're just resolving it to the view directory within this module. So this is the sort of thing that we can actually do in every single module. Typically, you'll only need to configure the template map resolver and or the template path stack in your different modules. So you can actually override the maps through any module, or in your config autoloads, you can override them there as well. And I've actually done this a number of times, which is a really nice trick. You can, since all the configuration gets merged together and then those autoloads get merged at the end, you can override anything at that point. So you can point things at different locations very easily. Now we get to the controllers, and we want to be able to provide data to the view, basically, right? And since we don't actually have the view injected, we need to have some way of doing that. So the standard way to do this is simply return a value from our controllers. So we've got here a hello controller with a world action. And the most explicit way that will always work, and basically the nice part about this too is it bypasses a whole bunch of listeners. So listeners will skip the result returned from this because it's a fully populated view model with a template. So all we do here is we create a new view model, and we provide it some variables. So we're actually doing that in the constructor. There's also a set variables method that you could call if you wanted to. And then we say set template, and we say hello/world. You'll notice that there's no suffix to this. It's just a name. It's an identifier. So that's the thing to remember about the templates within Zen Framework 2 is that they are just identifiers. They don't necessarily need to resolve to a particular file name. And in fact, you can override it so it resolves to a completely different file name if you want to, which is fun. And then we return that model. Returning that view model is fantastic. All we do is we do that, and then all of our listeners and strategies will see that model, and when we get to the rendering portion of the workflow, it's going to take that view model and try and render it. One of the things it also does is it will go and actually inject it into that layout view model. But behind the scenes, all you need to worry about is, am I returning a view model? Now, the next way to do this is a semi-explicit fashion. And in this case, we will create a view model, and we'll just simply return it. We're not going to set the template. Now, what will happen is the inject template listener is going to say, hey, here's a view model without a template. Okay, well, we know what the controller is. And we know the action that was pulled, and so we will create a template identifier based on that information. Right now, the default rules will make this hello/world just like we had in the previous one. One thing that may change for beta 4 is that we may prefix also with the namespace that we're currently in. And that's simply to provide disambiguation between modules. The next possible way to do this is implicitly. And in this case, all we're doing is returning an array, an associative array. And so again, this is where all those different strategies and listeners that we set up by default help us. Because now we can return this nice little array, and they will take care, all these sort of strategies and listeners will take care of creating a fully populated view model for us, and making sure it's injected in the layout view model. So this is the easiest way to do things, is simply like this. It requires a little bit of magic, and it's less explicit. And that would be my only note to people, is that I would typically tend toward more explicitness, so setting the template precisely, creating a view model, and all that stuff. I would tend towards that rather than relying on the magic. But the magic is there to make development faster and easier for you. Now, the next task I chose to tackle was, how can I choose an alternate layout? And there are several different ways of doing this. First one is via configuration. And I showed you earlier some DI configuration for setting up resolvers. There's a similar thing for the default rendering strategy. And all we have to do here is set the layout template parameter, and we can save some other layout. And at this point, assuming that this configuration has precedence, in other words, it's merged late, then this alternate layout template will be used throughout the application. So this is a really nice way to do it application-wide, is through the configuration. Again, this may change slightly for beta 4, but this should continue to work even through beta 4 if you haven't set up your service managers and everything. So this is a really nice way to do site-wide. The other way to do it is through a controller. And I mentioned that we have layout plugins for both controllers and also for the view scripts. From a controller, we call this layout, or we can say this plugin layout, either one. So line 10, we grab that layout plugin, and then we simply call set template on it, and we're done. So we can choose from within a controller to use an alternate template very easily as well. Now, I mentioned that there's also a view helper, and so within a view script, you can do exactly the same thing, and it looks precisely like it did in the controller. You simply say this layout, set template, some other template, and at that point, it will be done. Now, an interesting thing, I mentioned that there are you can do trees of view models and everything. With the PHP renderer, things are done slightly differently than other renderers might work. And basically, in order to allow the view scripts, individual view scripts, to influence the layout, we actually render from the deepest nodes first, and then on up to the tree, to the root, which is the layout. This is going to be very familiar to those of you with Zen Framework 1, because it's exactly how Zen Framework 1 works. But it is something to keep in mind as you work with other renderers. For instance, if you were to use a mustache renderer or the JSON renderer, it will actually instead of depth first approach, it will start from the root node and move downwards from there. So you wouldn't be able to necessarily hint to the layout template at that point. But with PHP renderer, it works just as you would expect from Zen Framework 1. Now, the other way that you might want to choose an alternate layout is you may want to choose an alternate layout for an entire module. I just saw a question pop up in Q&A. Jason Silva asks, he wants to confirm that a view helper is able to change the layout that gets used. Yes, absolutely, Jason. As long as you're not actually in the layout view template at the time, yes, you can change the layout view the layout view template at any point from within a child view script. Now, the other place you may want to change the layout is for an entire module. So, for instance, if you know that the current controller is one that your module controls, you can actually say, hey, once I know that the controller chosen is in my module, I want to use this alternate template. A really good example of this would be for like admin screens. You may want to say, hey, when I'm in my admin template, use the admin layout instead of the site-wide layout. So in here, I didn't do the whole boilerplate in here, but basically we have a listener called onRouteFinish. So it would be basically a listener on the route event at low priority, so negative priority, so after we've already matched. We're going to listen to this, and we'll grab the route match, and we grab the controller out of the route match, and we check to see if the namespace matches our namespace. If not, then we return, we're done. Otherwise, we go and we grab the view model out of the event, and we set the template. So the view model in the event, again, is the layout view model. And so from there, we can set the template, and that changes the template for the layout for this execution cycle. So this is some boilerplate that you'll see quite often is choosing to do particular actions when the namespace of the current controller matches. Now, another thing that you can do is use multiple view models. I mentioned that you can do trees of view models within the layouts. So we're going to do that here. We're going to add a sidebar to the layout as well. So within our hello controller world action, we're going to do two different things. Just like we did before, we'll return a view model that has a message. But we're also going to attach another view model that represents a sidebar to the layout. So in lines 9 and 10, we do exactly that. We create a new view model and we populate it with data. We'll pretend that there's a get menu data method or something like that within the controller. And we'll grab that data and will become the variables for the view model. And then we grab the layout and add a child. So you'll see here, add child. We're calling it, we're using the $sidebar that we assigned in line 9. And then we're assigning it to sidebar. So basically, it's going to capture the content of that to the layout variable sidebar, which we can then simply echo out within the layout itself. So what's cool about this is we now have two view models attached to the layout when we get done. By default, when you return a view model from a controller, it's going to be attached to, I believe, the content variable within the layout. You can alter that if you want to, but by default, that's what it will use. So now we have content and we have a sidebar, and the layout will be able to render both. So this is a really nice way to do things. And you're not limited to just one or two or whatever. You can add as many children as you want. So in this particular example, we're showing doing several different ones. So lines 9 and 10 are, not 9 and 10, 12 and 13 are just like what we had on the previous slide. So we're taking that sidebar, we get the menu data, good to go. We're also adding a nav one. So we're grabbing navigation data from somewhere, and we're adding a nav child to the layout. That's lines 9 and 10. And perhaps some alternate footer content, so lines 15 and 16. So you can do a whole bunch of fun things here. You can basically say, I need to be able to manipulate or inject different areas of the layout, and so you can use child view models to do that if you would like to. You can also render without a layout. So what's interesting here is, for instance, you may want to have a snippet of content. A really good example here is when you're doing XML HTTP request from JavaScript. You may want to actually just have a snippet of content. So you don't want the layout at that point. So what you do here is you take the view model and you mark it as terminal. And what you're saying here is, I want this to be the new root node for rendering. So what will happen at this point is one of the strategies will take a look and say, hey, has this particular view model been marked as terminal? If so, I'm going to make this the root view model for this particular request. So what we've done here is line 12 does that, model set terminal true, and when we return this model, it will say, hey, do not render a layout. This is the new root of the execution. All children under this will be rendered, but we want it to start rendering at this particular child. And finally, of course, I mentioned before, you can choose not to render a view at all. And to do that, you simply return a response. You can use getResponse within an action controller to get the response. And if you return that response, then we will basically be saying, hey, I don't want to render anything. Usually, you're going to set the status code. You may want to populate it. Typically, you don't want to do view-related things within the controller, but if you absolutely need to, you can do that. So that's the way that you bypass rendering. Now, let's get into a more advanced topic. I mentioned before one of the goals was making it very easy to alternate content types. So perfect examples here. We have an API and we want to be able to serve JSON when we're working with XHR, but we want to be able to serve feeds when, Atom feeds or some other sort of feed when we've got somebody requesting XML. So this would be machine-to-machine communication. So we want to be able to do this very easily. The way I look at it is an egg is not always an egg. We've got the standard egg, but we could make it a hard-boiled egg. We might want to poach it. We might want to scramble it, fry it, make egg benedict, make deviled eggs, whatever the case may be. So what we want to do is our renderer is going to be taking care of that. The renderer is going to say, my specialty today is hard-boiled eggs, and it will go and create that for you. And it's going to be doing that based on what the person orders. So if the person says, hey, I want eggs, do it this style, then you can return it in that style. You're not going to give them quiche when they ask for an omelet, right? So this is the idea here. Serving JSON is pretty easy. We have a JSON strategy. And, the various rendering and response strategies are all under ZenView strategy. With the JSON strategy, we have a couple of different ways that we can make JSON possible. First, if you return a JSON model, so a ZenView model, JSON model, if you return a JSON model from a view script and the JSON strategy is active, it's going to use the JSON renderer at that point. The other way that you can invoke it is to, in your accept header, tell it that you prefer application/JSON. And if that's the case, then the JSON renderer will also be invoked. What it does is it disables the layout, and then it renders a nested JSON object based on the model and its children. So it's a really, really simplistic way of doing things. That said, you can do some really fun things. You can actually set a string template where basically it goes through and it says, okay, content is going to go under this key, status code is going to go under this key, that sort of thing. It's a very simplistic way of doing JSON. It will work for a lot of general purpose use cases. I would recommend typically you're going to alter the renderer and use an alternate renderer so that you can do some custom output. One of the things I often see is people include the status as part of the key within there and then the actual payload as a separate key. And there's very easy ways to do that. So the way you do this to register it, we've got a module class here, and again, we're doing this on route finish. What we may say here is, hey, we match the namespace, or you may just say, hey, this is going to be a general rule across my application. But what we do is we grab the view object from the locator, and then we grab the JSON strategy from the locator as well, and we simply attach it to the view. We give it a high priority. So what this does is basically if I don't return a JSON model or the accept header is an accepting application JSON, then my JSON strategy is going to fail. It's going to say, hey, I actually can't return a renderer at this point. So then it will fall back to the default rendering strategy, which gives us back a PHP renderer. So this is a really slick solution. I don't even have to change any of the defaults. I'm just adding another strategy to the stack, which is a really great way of doing things. I just realized line 11 is incorrect. There should be view events attached, and I will fix this again before I post the slides. Now, serving feeds is pretty much the exact same thing as serving JSON. Again, if the feed strategy is registered, if you return a feed model, we'll select the feed renderer. And then if the accept header prefers either application Atom XML or application RSX XML, it's going to use the feed renderer as well. Just like the JSON renderer, it disables the layout, and it renders the feed based on the contents of the view model or the feed model provided. It's a little more complex than that. The feed model actually can compose a Zen feed writer feed object, or it can generate one based on the variables that you've assigned, and it will use the feed factory at that point. What that means, though, is that the variables in the feed have to follow a specific format that the feed factory can actually utilize. However, it's a nice way of saying, hey, I've got a feed that I want to provide and doing it. Again, this is a case where you may want to provide your own feed renderer that goes through and takes the data and sets it up in the appropriate structure for you so that you can actually return the same data payload from an action and have it render as either JSON or a feed or within the HTML that you want to do for your PHP renderer. But that said, we do have the basics in place, and we're trying to make it as easy as possible. One of the ways I think about these various strategies and renderers is they give you blueprints for creating the custom strategies and renderers that you want to use. So you can also do combined strategies. One of the things I talk about in talks is that you should pay attention to the accept priority. There's a queue priority value that you should be using with your accept headers. And basically with those you're saying, hey, I prefer this, but I can also use these particular formats in this particular priority order. The other thing is that when you do combined strategies, you can have a single rendering strategy that can return multiple different renderers based on the criteria that you want to look at. Kate Hetzel just wrote in the Q&A wondering if it's possible to change the render depending on the requested file extension. And this would be exactly how you would do it. You would create a custom strategy that would take a look at the request and determine what to do with it, what renderer to accomplish. In this particular one, I actually lifted this directly out of the quick start that we have on the website. We're going to look at the accept headers. You're not limited to looking at the accept headers. You can look at anything. You can look at the request URI and see what the suffix is. You might check and see what the matched route was. There's all sorts of things that you can look at. I'm looking simply at the headers in this case to show how I might prioritize based on the accept headers. So first off, I get my request. I check and see if I actually have an accept header. If I don't, I'm going to use the PHP renderer. Otherwise, I grab the accept header, and the accept header has a get prioritized method. And what this does is it gives us a priority queue with each of the different MIME types based on the queue priority that we're done. So it will loop through them from highest priority to least priority. And so we get our media type. And then I go through and I check the media type against each of these. And if it matches particular strings, then I return particular renderers. This example is making an assumption that I have an attached JSON renderer, feed renderer, and PHP renderer. You'll notice I'm using strpos in here. The reason being that it's not uncommon to add vendor extensions to the content type. So you might have application/JSON plus MWAP plus v3 or something like that. And so we just are interested in the very first part of it and making sure that it matches the default expectations. So if we see application JSON, we're going to return a JSON renderer immediately. If we see RSX XML, we'll return the feed renderer, and we'll set the feed type to RSS. Same thing with Atom plus XML. We'll set it to feed type to Atom and return the feed renderer. And if after looping through all of those we haven't returned yet, we'll return the PHP renderer, and we're done. So this is one way that you could do it. Again, there are multiple ways that you could do this. If you want to look at file extensions, you could. If you wanted to look for specific routes, you could. This is just to give you some ideas for how you might implement a custom strategy. So we've gone through a bunch of different things. There's an immense amount of flexibility in the view layer at this point. And I'm really pleased with some of the things I've been able to accomplish with it already. Now, that said, it's not perfect, and there are some things it does not do. I say yet here. I think some of these things we will be making possible. Other things we won't be making possible simply because they're application specific. But some common things that you may need to do include, for instance, helper injection. A lot of the helpers actually have dependencies, and you may need to put those in. So a really good example is you may want to set the base path. There's a base path helper, and you need to set the base path in there if you have something different than just slash. So in this particular example, we grabbed the base path in line 5 from the request. And in line 9, we actually set the base path for the base path helper. Doc type is another case. You're probably going to need to set the doc type at some point. And here I'm just hard coding it to HTML5. You might use a configuration value. Whatever the case may be. You're going to need to inject that somehow. Same thing with the URL helper. You're going to need to inject the router at some point. And so we grab the router in line 8, and then we inject it into the URL plugin. So this sort of thing is still necessary, and you'll see that it's still an event skeleton application. We do a lot of this stuff for you right off the bat. But you're still going to need to do this, so be aware of it. Another thing, you might want to be able to see the layout with some configuration, and this is a tip that I got from Rob Allen. What this does is it grabs the configuration out of the event, and this is the event that's happening during Bootstrap. It grabs the configuration, and then what it does is it grabs the layout view model, which is the view model in the MVC event. And we grab that, and we then set a config variable on it that is equal to the layout configuration that we had, that we retrieved earlier. So this is really nice because then you can see the layout with things that are specific to your application. You might have flags that you wanted, some variables that you're going to utilize and see things with that sort of thing. So this allows you to do that very easily. And this is something that Rob has done in a test application that I thought was really cool. So wrapping up, we covered a bunch of things today. And it's been about 50 minutes in now. We assembled ingredients. So we took, this is our view models. We assemble our ingredients that we're going to potentially use to give our representation. We provide recipes via our resolvers, and the recipes are the, what we're actually going to render, the resource that we're going to use, the instructions. We prepare the recipe from the ingredients, and the renderers act as our chef in the kitchen, and they go and they take that recipe that we pulled from the resolver and use the ingredients at hand, and we do something with them. And we may have some prep cooks around to assist us in the form of the view helpers or the renderer helpers. And then, of course, we have a top-notch waiter that takes the orders, delivers them to the chef, and takes what's returned and gives a nice presentation to the diner who has requested all this. So this is the way to think about it. There's a lot of people talking and moving and doing stuff, but each of them has a very discrete task that they're responsible for. There's a number of resources. We've got the slides here. I have them posted. I will update them after this presentation to correct some of the errors that I discovered. There's also the ZenView Quick Start. That's the bit.ly link L4CFJS. This is actually goes through a lot of the stuff I covered today is actually covered in the Quick Start already. So that's a good resource. There's a lot of examples, a lot of code you can cut and paste and use in your applications. Rob Allen, Acrobat, for those of you who know Acrobat.com and his tutorial, one of the things he did as he was reviewing the view layer for inclusion was he went and created this ZF2 test app. And you can clone it. What's really cool is when you clone it, you can assign it to a vhost, and you can actually see the results of all these different things. And he goes through a bunch of different examples of things you can do with the view layer. So there's some really cool things. I'm going to start going through questions right now. If there's feedback, you can go to the ZF2 subsite, or you can tell me on Twitter. I'm going to go through the questions as quickly as I can, and hopefully I can get to all of them before we need to cut off for today. So starting at the beginning, Vahid Bazaz has asked, when will Zen 2 be released? Sometime during the summer. I'm not going to give a specific date, but sometime during the summer we will be releasing a stable version of Zen Framework 2. He also asks, can you discuss about the move from Zen 1 to Zen 2? How difficult and simple will it be? That's actually one I can't discuss right now. It's still to be determined. I've done some work to provide an emulation layer, but that was several months ago. Things have changed since then. It is a priority for us, but it's low priority over getting the stable framework out. He also asks, Vahid Bazaz also asks if Zen includes something like the widget in Yi. I'm not sure exactly what widgets in Yi are like. Most likely they are analogous to helpers and within the view layer in Zen Framework. Vahid Bazaz also asks if I can address any rationalization of localization inside the view layer. Other than saying that that's where it will happen, no. We're currently working on a new internationalization and localization layer for Zen Framework 2. Ben Schultzen is spearheading this. He hopes to complete in the next week or two so that we can include it in Beta 4. At that point, I'll be able to give you more concrete information. Most likely, we will be providing a variety of helpers, however, to make this a fairly trivial task to accomplish. I'm looking at Drago's question. He's talking about componentization and the ZF2 view layer. I'm trying to see what he's saying here. Helpers, he's asking first, how will the helpers look in Zen Framework 2, as in ZF1, their methods inside classes, and HTML would have to be realized in string way. This is actually how they still work. The difference is that helpers either have an invoke method or they don't. If they don't have an invoke method, when you call the helper, you retrieve the helper object and you do some and you call method off of it. If it has an invoke defined, then you can invoke it as if it were a function, and it will typically proxy to another method on the plugin itself. So this is, you do things in strings. The nice part is that you do have access to the renderer itself, which means you have access to the escaping and all that stuff. What that allows you to do is, as we finish our escaper mechanism, which will provide context-specific escaping, like for attributes versus content versus a variety of other things, you'll be able to choose a correct escaping mechanism as you build up the strings. Jesse Hernandez asks if a module can override the passport key in the template map resolver. I believe I already answered that, but absolutely. And you can do it a variety of ways. The configuration, we do a merge configuration, so there's a variety of places that you can override paths and keys, which is really great. Dmitry Belyakov mentions that RouteMatch get controller doesn't work with controller aliasing, in which case you can use eGetTarget. So Dmitry, there's a couple of things here. First off, when this particular event is triggering, we actually don't have a controller yet, so that's going to be a problem. Second is that we are recommending that people don't use aliasing for controllers for precisely the reason that we want to make sure that we know the full controller name as we work with things. So this is the better approach at this point. It looks like somebody's asked if I can go back to the other resources, so I've just done that at this point. Dimitri also asked, does he need to go extend MVC Bootstrap to introduce custom strategies for 404 and exception pages? Actually, you don't need to. What you can do is you can provide DI preferences. So you can create your own strategy classes and say that when it calls this class, you prefer to use this class. And that's possible with DI right now. And what that allows you to do is substitute your implementation for the one that the framework provides. Since you pulled all of the strategies out of the DI container currently, this is absolutely possible, which gives you a whole bunch of flexibility here. Brian Zwar asks why I return if the namespace doesn't match instead of doing the work if the namespace does match. The reason being is I would prefer to return early and keep the actual work of the method within the method instead of inside of a conditional. It's a preference, coding preference that I have at this time. I hope everybody was able to learn something today. It looks like I've blown through all the Q&A at this point and answered them all. You can go to the framework.zen.com/ZF2. Gives you some links to a variety of resources, including the IRC channel that we use for ZF2 development, and also links to the ZF contributors mailing list. So if you have further questions, those are good places to go. Thank you for joining me today, and we will talk again sometime.